Billy Goat Trail Claymation by David Brooks. Around 510 million years ago, a volcanic island arc began to move toward ancestral North America. It continued to move until around 450 MA, where it finally accreted to North America and was known as the Taconian orogeny. Here is a rough location of the C&O Canal that was built millions of years in the future. An imminent result of collision was the formation of migmatites. Migmatites begin as a rock of various composition, then once partial melting occurs, the felsic minerals are squeezed out and the mafic are left behind. This is often seen as two rocks alongside one another, one with granitic composition and another with mafic composition. One of the sedimentary structures seen along the Billy Goat Trail are graded beds. Graded beds of the Billy Goat Trail form due to turbidity currents. Turbidity currents carry sediment in the circular fashion shown here and deposits them in a coarse to fine-grained manner. Rocks of the Billy Goat Trail. Prior to accretion, greywacke sediments were deposited in the closing Iapetus Ocean. Accretion turned those sediments into the meta-greywacke rocks of the Billy Goat Trail. Schist. Schist forms due to metamorphism, which results in foliation. Here you can see the transformation from irregular arrangement of minerals to regular arrangement of minerals. The schist found along the Billy Goat Trail is abundantly white mica schist. Gneiss is a higher grade metamorphic rock. Gneiss also undergoes foliation but results in banding of felsic and mafic layers. On the Billy Goat Trail, the gneisses are also folded, which shows up in the banded layers shown here. Amphibolites. Amphibolites are also high-grade metamorphic rocks. Amphibolite begins as an igneous rock abundant in the mineral amphibole and is metamorphosed to form the amphibolite seen along the portions of the Billy Goat Trail. The felsic mineral present in these amphibolites is plagioclase feldspar. After the Taconian orogeny, another landmass had its sites on North America. This was known as the microcontinent Avalonia. It began moving toward North America in a southwest fashion until about 360 MA, where it fully accreted to North America and was known as the Acadian orogeny. The Acadian orogeny brought more structural formations and deformations to the Billy Goat Trail, the most important being the Lampreyfere dikes. Dikes form where joints or fractures in a rock and magma fills those joints, leaving an igneous rock in place. The Lampreyfere dikes can be seen along the Billy Goat Trail and across the Potomac River in the fashion shown here. Deformational structures such as tension gashes and boudinage also can be seen along the Billy Goat Trail. Tension gashes form from shearing a rock and opening up gashes in that rock, which are then filled with a silica-rich water, leaving behind quartz-filled gashes. The example shown here shows left lateral shear. Boudinage is French for sausage and appears as a vein is deformed, in this case left laterally, breaking it into small pieces taking on the shape of an eyeball or sausage. Here is an overview of the trail and the rocks seen in order as you hike along the trail. Metagreywackes, schists, gneisses, amphibolites, then migmatites. Last topic of discussion is the anomalously straight Mather Gorge and the displacement of the Lampreyfere dikes in the gorge. Mather Gorge appears straight as shown here but is unexplained. Our class took strike and dip of joints plotted on a staring net here and the trend and plunge of fold axes plotted on a staring net here. The scattered arrangement of the data seemed inconclusive about the explanation of a straight gorge, but leaves me to conclude that the dikes are displaced due to the natural orientation of the joint. In order to top it all off and leave you with a smile on your face, here is an image of the water plus gravity combination we all know and love. The end.